Okay, Kedrick. So today we're going to learn how to balance this kind of equation that in the previous meeting we really struggle on to balance. Why? Because firstly, it's not just about balancing the number of atoms between left side and right side. At the same time, we also need to balance the number of charges. So that's our struggle. So when we balance the number of atoms, remember the thing when we add water thingy, when we need to balance the number of atoms, the number of charges always is still not the same between left side and right side. And when we want to balance the number of charges, then we ruin the number of atoms again. So it's very hard to solve. Okay, so now there's a method here that we call the half reaction method. So what does it do is they separate between the oxidation and reduction reaction, become half and half reaction. That's why it's called half reaction. So we do it separately. You get the idea? So we're gonna do it with a longer process, more detailed step by step. Yeah, so we try to divide it into into smaller steps. It's longer, but it's now much easier to understand and much more possible to do. Okay, let's do it. So first step is, yes, divide it into half, oxidation and reduction. So for oxidation is absolutely the iron, because it is from 2 plus become 3 plus. And then the reduction is for the Cr2O7. Why? Because in Cr2O7, yeah, the number of charge for the Cr is positive 6. Yeah, obviously of course you know how to do it, Kedrick, right? So you know how to find this already. So I'm going to skip the process of finding the positive 6. But if you forget, you can ask me later. Positive 6 become positive 3, so it's a reduction. Now let's do the reduction. We always do the reduction first. Well, not always reduction. Let's see later. We always do from the one that have the oxygen atom first. So first step, find O. So which one have the oxygen? This one, right? That's why we start from the reduction first. Find O and then add H2O to balance. Now look closer. I just rewrite the equation and then add H2O. But why 7? Because there are 7 oxygen here, so obviously we have to multiply by 7 to balance it, right? Okay. Now second step is balance the H plus. Now because there's H here but there's no H here, so we have to add H on the right side, right? So we add 14H plus. Why? Because there's multiplied by 7 here, and then it's H2, 7 times 2, 14. So I have to add 14H plus. Remember, it's H plus, yeah? There has to be plus there. And then the third step is balance the equation. By this I mean the number of atoms. So yeah, the only thing we need to add here is just the times 2 for the Cr3 plus, because there are 2 Crs here, and then I think the rest are the same already. The H, the O, everything okay already. And then okay, the atom are balanced. Now we balance the charge by doing step 4, add electrons to balance the charge. Let's count the number of electrons for each side. So for the left side, obviously for this one is -2, this one is 14 plus times plus 1 become plus 14 is positive 12. For the right side, it is 2 times positive 3 become positive 6, and it's 0 for here. Oh sorry, my hand is really shaking here. Okay, so the total is positive 6. Now the charge is not balanced, obviously, so how do we balance it? We add electrons, so we need to add 6 electrons here, add negative 6, become this. Notice that I just rewrite this equation, but with the 6e added here. This means 6 electrons. So the good thing about this method is because you separate it so detailed, you can add only electrons here to balance it. So it's very easy to balance the charge after you balance all the atoms. Okay, and then done. That's it. So we successfully balance the reduction part. Yeah, this one. So these are all both balance in terms of atoms and balance in terms of charges. Now reduction part done. Now let's do the oxidation part. So Fe2 plus become Fe3 plus. Let's do it on the next page. Okay, so how do we balance this? Very easy, because there's no O in here, so we skip the first part and the second part. Nothing to do with O and H because we don't do H2O thingy. So we go straight to the third step and the fourth step. Only 2 steps. So that will become the first step and the second step in here. So just third step, balance the electrons here. So add electrons to balance the charge. So because it's 2 plus here and 3 plus here, we add the electron, 1 electron only on the right side. Yeah, now it's balanced. So 3 plus and 1 minus become 2 positive, just like this. Done. And then multiply to match the number of E. So we'll multiply by 6. Why? What do we match here? The number of E, because it was previously in this reduction part we have 6E, so we have to multiply by 6 to have 6E as well. We want to make it the same. Final step, combine all without E. Okay, we combine all. So the final equation that we got for the oxidation is this. Final equation we got for the reduction is this. Let's combine them. So let's do the left side first. For left side here we have 6Fe2 plus. Done, no more. And for this, the left side we have this 1 2 3. Okay, without the, we don't need to write the 6E, so just CR 207 plus 2 minus and 14H plus here. And then for the right side we have 2Cr3 plus and 7H2O. And then for the right side we have 6Fe3 plus. Again, without the E, we don't need to write. Why? Actually there's E, right? But since both sides have 6E, on the this one have on the left side, this one on the right side, imagine if, even though if you write the 6E and 6E here, okay, in maths we already learned if there's left side and right side we can eliminate it if it's the same thing, right? So it will be eliminated anyway, so just we don't need to write that. So this is the final step. Done. This is the final equation. This is the answer. If the question asks for in acidic solution, later question like this, there will be 2 versions. They will either ask you in acidic solution. Oh, my battery is too low for the flash. Or either for the basic solution. Now this is for acidic solution. Why? Because we end up in H plus thingy. H is acid, right? But how if the question asks for in basic solution? We need to base. There's no H plus in base. So how do we change this H plus into base, right? Here's the thing. So we rewrite the equation again, and we add 14OH minus to both sides. See? This one, these two, right? Why do we do this? So that this and this H and OH can combine into H2O. So there's no more H plus, so there's no more acid. At the same time, There's OH here, so we create the base. So now it will become basic solution. Here, done. And for the last part, we just simplify this because there's 14H2O, there's 7H2O here. You know, in maths, we know that we can simplify this. We minus both by 7, so it's gone. On the right side, it's gone. Here we have 7H2O, done. See the difference? In this we have H plus because acidic. In here we don't have H plus. We have OH minus, which is the base. Done.